Good morning, everyone. My name is Kratika, and today I will be presenting on the environmental impact of PCB contamination in the Hudson River and the ongoing cleanup efforts. This presentation is a part of my coursework for Global Environmental Health in the spring 2025 semester. Next, we will talk about the purpose of this presentation, which is to examine the historical contamination of the Hudson River by PCBs, assess their environmental and public health impacts, and analyze the effectiveness of the EPA's cleanup efforts. About discussing the objectives, throughout this presentation, I will be investigating the sources of the PCB contamination, assess the environmental consequences, analyze public health risks, examine the EPA's cleanup progress, and discuss potential future steps for further remediations. Next, we will be discussing table of contents, which comprises of purpose and objectives, source and history of PCB contamination, PCB in Hudson River surface water, health impacts of PCB exposure, plan for dredging Hudson River dredging project data, EPA's cleanup plan, summary of findings, and some references. Now, going back in time, we will discuss sources and history of PCB contamination. It started in 1947 when General Electric discharges an estimated of 1.3 million pounds of PCB into the Hudson River. In 1980, the Comprehensive Environmental Response Compensation and Liability Act, also known as Superfund, is enacted. In 1984, the Hudson River was designated as a Superfund site, but the EPA's issued a no action decision on PCB contaminated sediments. In 2000, EPA completes the reassessment of RIFS and issues a proposed plan for cleanup of PCB in the Hudson River. In 2002, EPA signs a record of decision to remove PCB contaminated sediments from the upper Hudson using environmental dredging methods. Now we will discuss about PCB in Hudson River surface water with the help of a pie chart. Studies conducted between 1975 and 2007 shows that at least 80% of water samples contained PCBs exceeding water quality standards, with only 20% of the samples showing no detectable levels. This highlights the persistence of PCB contamination in the river's ecosystem. Now, with the help of a bar graph, we will discuss about the health impacts of PCB exposure. Exposure to PCB is a major public health concern. Studies have linked PCB exposure to an increased risk of cancer, immune system suppression, and developmental issues. The data presented in the bar graph compares average PCB levels in outdoor air and human blood across different communities. Next, we will be talking about plan for dredging the Hudson River. To address PCB contamination, the EPA issued a record of decision in 2002, mandating the removal of 2.6 million cubic yards of PCB contaminated sediments from a 40-mile stretch of the upper Hudson River. There were three sections divided. The section first comprises of Fort Edward Dam to Thompson Island Dam. Section 2 comprises of Thompson Island Dam to Northumberland Dam, and Section 3 comprised of Northumberland Dam to Federal Dam at Shaw. The dredging occurred in an area of 5-acre certification units, with the progress to be mapped annually. Next, we will discuss about Hudson River dredging project data. This bar graph compares PCB concentration in Hudson River before and after the dredging efforts were made. The data from 2004 to 2008 represents pre-dredging conditions, while the data from 2017 to 2022 illustrates how there is a reduction in PCB contamination following up the cleanup efforts. We can clearly see in the bar graph that the average total PCB content reduced over time. Next, we'll discuss EPS cleanup effect with the help of a line graph that compares average PCB concentration in the river sections between the year 2002 and 2005 and 2016. The blue line represents the earlier period, while the red dashed line represents the year 2016. The decline in the PCB level over time is clearly visible in the line graph. Next, discussing about the summary findings of the presentation. To summarize, General Electric was primary source of PCB contamination in the Hudson River. PCB persists in the environment, impacting aquatic life and accumulating in the food chain. Human exposure, particularly through fish consumption, poses serious health risks. Dredging has significantly reduced PCB contamination, but residual pollution remains a concern. Ongoing monitoring and potential additional remediation will be necessary for the long-term recovery of Hudson River's ecosystem. By this, we come to an end of this presentation. Thank you so much for your time and watching the presentation.